The overall goal of this procedure is to produce nanoscale thickness transmission electron microscopy specimens for studying combined electrical and mechanical load effects on material microstructures with negligible material temperature rise.
This method can help answer key questions in the electrically assisted deformation field regarding the role of current densities in increasing formability of metals by utilizing in situ TEM observation. The main advantage of this technique is that the nanoscale thickness test section rejects heat to the bulkier supporting frame at a high enough rate to prevent significant temperature increase.
To begin the procedure, spin coat a 180 micron thick silicon wafer with sufficient positive photoresist to form a 7.5 micron thick layer. Bake the wafer at 60 degrees Celsius for 2 minutes and then at 115 degrees Celsius for 90 seconds. Place a chrome and glass mask over the coated wafer and expose the wafer to UV light. Develop the pattern with the appropriate photoresist developer. Bond the patterned wafer to a 500 micron thick silicon support wafer with a low melting point temporary adhesive. Apply the adhesive uniformly to prevent excessive heating and etching damage to the patterned wafer. Then, etch through the patterned wafer with deep reactive ion etching using the Bosch process. Monitor the etching rate with a profilometer. When etching is complete, soak the etched wafer in acetone overnight to dissolve the temporary adhesive and the photoresist. Then, deposit 2 to 3 micrometers of silicon dioxide on both sides of the wafer by plasma-enhanced chemical vapor deposition at 300 degrees Celsius.